Hello. In this video, we're going to be solving some more systems of equations using a table method. Okay, so this system that we're going to start with is x minus 2y equals -8. And the second equation is 3x plus y equals 4. So when you're determining the dimensions of your table, the first thing you're going to look at is for the equations that you've been given, how many different kinds of terms are represented. So in this case, I have a term with x, a term in y, and I have a constant term. That's 3 different terms. And in the second equation, I have the same 3 types of terms. So I'm going to have 3 columns in my table, and I've got 2 equations, so I'm going to have 2 rows. In my table, I will have a column for the x terms, a column for the y terms. I'm going to have a little bar for the equality sign, and then my constant, which I will use the letter k for that. And that selection of k is arbitrary. I could have chosen any other letter of the alphabet that wasn't x and y. It's just a placeholder. Okay, so in this first equation, x is 1x. So my coefficient for x is 1. The coefficient for the term that's y is -2. The sign is important. That has to be included in your coefficient. And then the constant is -8. For the second equation, we've got 3x. So the coefficient is 3. This coefficient for y is 1. And then we've got 4. As my constant. So the goal in the table form is basically elimination is what we're doing. So I'm going to try and add one row to the next and figure out, is there a way that I can add them together that will eliminate one of the columns and turn those values into 0. So here's what I mean by that. If I were to add the columns as they are, the total in the first column is 4. The total in the second column is -1. The total in the third column currently is -4. Well, none of those are 0, so that's not good enough. So I've got to figure out, if I look at the y's, that's a -2. If I doubled this second row, then the value for y's becomes +2, which would add up to 0. So that's what I'm going to do. I'm going to do a distribution across that row, across that equation, multiply everything in that equation by 2. So now my table becomes 1, -2, -8. That was the first row. The second row has become 6, 2, and 8. Still x's, y's, and constants. That has not changed. So now when I add a row to a row or an equation to an equation, you can see that the column with the y's adds up to 0. So I'm going to get 0 y's, 7 x's, and this is 0. So what this means is 7x equals 0. Which if you isolate for x, that means x has to be 0. That's the 0 product rule, that when 2 numbers multiply to make 0, 2 values multiply to make 0, one of them has to be 0. So if one of them is 7, the other one's got to be 0. So there's the value of x. And I can come back in to this equation here, either one, doesn't really matter, and do a substitution to figure out the value of y. So say we use this one, the 3x plus y is 4. Sub that 0 value in for x, like this. I get 0 plus y is 4. Well, that means that y has to be 4. So the solution to this system of equations is x equals 0, y equals 4. we'll do another one. Five x minus 6y equals 16. And 5x plus y equals 2. So in the previous video, I showed a couple of examples, one with an addition and one with a subtraction. This is also an example where a subtraction would be appropriate because I can see right away that the terms in x have the same coefficient. So if I subtracted the first equation minus the second equation, those x terms will go away. So in my table, just to see what that would look like, x, y, constant, I have 5, negative 6, and 16, and I have 5, 1, and 2. So first row minus the second row, I'm going to get 0x, I'm going to get negative 7, and I'm going to get 14 here. 16 minus 2. So this part of the table tells me what I've just figured out is negative 7y is equal to 14. Divide both sides by negative 7, and you'll get y equals negative 2. Okay, so then at that point I look back at my equations and decide which one looks like it's the easiest one to substitute that negative 2 into. And I'm going to go for the second one because it only has one y, so that's the quickest one for me to do that substitution. So 5x plus negative 2. So I'm just taking that value that I just solved for and substituting it in where the y was. So 5x, I'll add 2 to both sides, it's 4, and divide by 5, x is 4/5. So that solution doesn't work out to be an integer, and that's fine. Solutions can be decimals, they can be fractions. There's nothing wrong with that. So sometimes it's required that you show that step of the division, and sometimes I do that in color just to make it a little easier to see what was done from one step to the next. All right, so the solution to that system of equations is x is 4/5 and y is negative 2. So one of the questions that I often get with this strategy is, well, that's great if all of them are in the same positions, x, y, x, y. What happens if it doesn't look like that? What if what you're given doesn't line up that nicely? Not a problem. So we're going to do another one to show what that looks like. So we've got 2x minus 3y equals 0. And the second equation given is x equals 3y minus 3. So I am going to start with, I'm going to rearrange them so that they do have the same terms in the same location. And currently they're not. I've got the x's and y's to the left of the equality sign, the equation, the equal sign, and then a 0, and that's fine. On the second one, the x is the only thing. It's been isolated. It's on the left on its own. So I have to make a decision. I either decide to bring the 3y over to the left so that it resembles the one above, or I bring that 3y over to the right so that it resembles the one on the bottom. And I think I'm going to do that because that's going to eliminate a subtraction or minus, and I do that whenever possible. So instead of 2x minus 3y equals 0, I'm going to rewrite the system as 2x equals 3y for the first equation. I'll say plus 0, I'll keep that constant showing up there. And then the second equation is x equals 3y minus 3. So I've lined up all of the terms that are similar terms or like terms. All right, so the table then has x terms are isolated to the left of the equality sign. There's my equal sign. I've got y's and constants. Coefficient is 2, 3, and 0 for the first equation. Second equation is 1, 3, -3 for the second equation. So looking at my variables here, or my columns, if I take the first equation and subtract the second one, I could solve for x. So let's do that. We'll call this one equation 1, and this is equation 2. Okay, so subtraction of equation 1 minus 2 results in 2 minus 1 is 1. 3 minus 3 is 0. 0 minus -3 is 3. So I end up with 1x equals 3. Well, that's nice. That gives me the value of x. That's one solution. And what happens if I want to find the value of y? In order to do that, I'm going to have to double this second one. So I'm going to use green here. So let's try distribute a 2 across that second equation. And now my table looks like this. I'm going to have 2 x, y, k, 2, 3, 0. And the second equation is going to be 2, 6, -6. So I've just doubled all of the values in that equation. It's been scaled up by a factor of 2. All right, so now if I subtract 1 minus 2, again, equation 1 minus equation 2, the x's will be eliminated. I could solve for y. I would end up with 0 here. I would end up with -3. And 0 minus -6 is just 6. So this means 0 equals -3y plus 6. And that means 3y is 6, which means that y, when you divide the 3 away, is 2. So the solution to that system of equations is x equals 3, y equals 2.